Hello and welcome. Mr. Martino here for your favorite teacher. Today we're going to talk about Pythagoras' theorem, which we can apply to the lengths of the sides of a right-angle triangle. Pythagoras was a famous Greek mathematician and philosopher that lived many years ago, around 500 BC. He came up with a relationship between the lengths of a right-angle triangle that we still use today more than 2,500 years later. That relationship is also very important in many different jobs and disciplines, which is why we still learn it in math today. He realized that when you form a right angle and complete a triangle with the shape, the three lengths of the triangle have a longest side, we call it C, and two shorter sides, we call them either A and B. His formula linked the sides of the triangle by the expression a squared plus b squared is equal to c squared. The longest side, C, is always the length that is opposite to the right angle, but it doesn't really matter which of the other two lengths are named A or B. His theorem, or rule, allows us to calculate the length of a missing side if we know the other two lengths in a right-angle triangle. The importance of this rule turns up in engineering, construction, aviation, surveying, and generally anywhere that you might need to rely on a right angle to do your job properly. If we look at an example, the question says that you need to show that the missing side has a length of 15 centimeters. Whenever a question asks the student to show, it's very important that all your working is clearly displayed for the examiner to mark. For this question, you should, first of all, label the lengths of the triangle as A, B, and C. Secondly, write out the formula that we will be using, that is A squared plus B squared equals C squared. Substitute the known values into the formula. Rearrange the formula to find the missing value, and then put in the correct units in your answer. We may also be asked to find the missing lengths of an everyday shape or scenario that relies on right-angle triangles, such as a ladder against a wall, flagpoles, and ramps. In this next example, we are asked to find the length of the line that secures the flagpole. Without being explicit said in the question, the inference is that this system is a right-angle system, and we can therefore use our knowledge of Pythagoras to solve it. Once again, we label our three sides, then set out our formula. We can then substitute the values into the formula to calculate the required answer. We may also need to use our knowledge of Pythagoras as part of a bigger solution to problems in geometry. There are times when the use of Pythagoras is necessary as part of the solution in a compound shape that either has right angles in it or can be broken up into smaller shapes with right angles. All in all, always be on the lookout for this type of setup so that you can use Pythagoras' theorem to solve problems. I hope this has been helpful, and you can always test your understanding by taking our quizzes or trying our worksheets available on the website. Thanks for watching, and this has been Mr. Martino for your favorite teacher.